Okay, this question asks to find e to the 3x sine x dx. Okay, so e to the 3x sine x dx. So I'm going to use the integration by parts, LIAT, logarithmic inverse trig, algebraic, trigonometric, and exponential. So with the exponential and trigonometric function, and it's the left to right order to choose u. So u is gonna be sine x. So du would be cosine of x dx. So dv would be e to the 3x dx. So b would be e to the 3x over 3. So integration by parts says ub minus b du. So sine x e to the 3x over 3 minus e to the 3x over 3 cosine of x dx. Oh, we have to do this again, integration by parts again. So now let's do u2, and then u2 is going to be same trigonometric and exponential functions that we see in the integrand. So u2 will be cosine of x, and du2 will be negative cosine of x dx, and dv2 is e to 3x over 3 dx. v2 is going to be e to the 3x over 9. So if you write this equation, it's going to be sine of x e to the 3x over 3 minus uv. So it's going to be minus cosine of x e to the 3x over 9 minus integration of b du. So e to the 3x over 9, and gonna be minus sine of x dx. So, okay, sine of x e to the 3x over 3 minus cosine of x e to the 3x over 9. This is going to be minus minus, so it's going to be positive. And, right, it's positive, but once you put negative, 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 it's going to be negative, right? So it's going to be negative e to the 3x over 9 sine of x dx. And this is integration. If you see this form, this is exactly the same. It's not exactly the same, but it is the similar format as our original function. So we're going to put e to the 3x sine x dx. And I'm going to put e to the sine x, e to the 3x sine x dx as some kind of variable u, because I'm kind of lazy to write it all. So I'm going to write that as a is equal to sine x e to the 3x over 3 minus cosine of x e to the 3x over 9 minus, this would be just same as 1 over 9 e to the 3x sine x dx, right? Because the constant can come out. So you can write this as a is equal to sine x e to the 3x over 3 minus cosine of x e to the 3x over 9 minus 1 over 9. And you can group them by a. So this will be just 10 over 9a is equal to sine x e to the 3x over 3 minus cosine of x e to the 3x over 9. So if you divide it by 10 over 9, this is going to be a is equal to sine x e to the 3x over 3 minus cosine of x e to the 3x over 9 multiplied by the reciprocal of 10 over 9, which is 9 over 10. So if you do the simplification, this just becomes 10 over, let's see, 10 over 3 sine of x e to 3x minus cosine of x e to 3x. So that's the answer, and we have to put plus c. I forgot that. So that's the answer, and let's find exactly the same format. So it's not 8. So it's not a, e, f, and it's going to be either b, c, d. But if you recall, our function was 3 sine x e to the 3x. So it's not going to be, so it's going to be c, e to the 3 sine x, and then minus cosine of x e to the 3x. Because if you group this, so this is same as c, because if you group it by e to the 3x, this is going to be e to the 3x, 3 sine x minus cosine of x plus c, which is exactly the same as c. So the answer for this question is c. Okay, this question asks to integrate the square root of x squared plus 4x minus 5 over x plus 2 dx. So I'm going to group the x squared plus 4x minus 5 into completing the square form and then group it by squared format. So this is same as x plus 2 squared, which is x squared plus 4x plus 4, and you have to add something to make it into negative 5. So in order to make negative 5 is equal to 4 plus square value, the square value will be negative 9, so it's going to be same as x plus 2 squared minus 9. Okay, so let's write the integrand. 1 to 4, x plus 2 squared minus 9 over x plus 2 dx. So this is trig substitution question. So our triangle will be something like this: x plus 2 and 3 theta, and this will be x plus 2 squared minus 9. If it was like a positive, I would have put that squared value in the hypotenuse, but since it is not a positive sign, when like the squared value and the constant are not added together, and rather it's subtracted to each other, which is why it's same as x squared minus a squared format, which is why I put x plus 2 is equal to 3 secant theta. And then x is going to be negative 2 plus 3 secant theta. So dx would be 3 secant theta tangent theta d theta. Okay, we have that. And then our x plus 2 squared value, x plus 2 squared minus 9 value, 9 secant squared theta minus 9. Okay, so we have that too. And now we have to find the bound, right? So bound would be solving for theta. So if you solve for theta, secant inverse of x plus 2 is equal to theta. Plugging in x equals 1, you get theta is equal to secant inverse of 3. Is it? Oh wait. Oh, I forgot over 3. Okay, x plus, secant, okay. I'll just rewrite this. Okay, so x plus 2 is equal to 3 secant theta. So x plus 2 over 3 is equal to secant theta. So theta is secant inverse of x plus 2 over 3. So x is equal to 1, then theta becomes secant inverse of 1, which is 0, because cosine graph is like this, and then secant is 1 over cosine value. And then x is equal to 4, then theta value becomes secant inverse of 2, which is same as cosine 1 over 2. Cosine 1 over 2, which is pi over 3. So there we go. We have the bound, and we just have to now solve it. So 0 to pi over 3, the bound. And then this value is the inside of the square bracket. So 9 secant squared theta minus 1, I'm going to group it by 9, so it's easier to compute later. And then x plus 2 is 3 secant theta, and then times 3 secant theta tangent theta d theta. 3 secant theta cancelled out. So this becomes 0 to pi over 3, square root of 9 secant squared theta minus 1 times tangent theta d theta. And then if you recall, secant squared theta minus 1 is tangent squared theta by the trig identity, and then it's the square root. So it's gonna be square root of, I'll just write it, tangent squared theta, so it's easier to visualize. Tangent theta, so this just becomes square root of 9 tangent squared theta times square, okay, I will not write like that. Okay, I'll just rewrite it. Okay, 0 to pi over 3, so square root of 9 tangent squared theta times tangent theta d theta. If you just see the square root of 9, that would be just 3. Tangent squared theta is just going to be tangent theta times tangent theta then, because of the square root. So this is going to be 0 to pi over 3 tangent squared theta, right? So this is just going to be 0 to pi over 3 tangent squared theta d theta. And if you recall, tangent squared theta is 3 secant theta minus 1, so I'm going to plug it back. 0 to 3 over pi over 3, 3 secant squared theta minus 1 d theta. And this is same as 0 to pi over 3 secant theta minus 3 d theta. And this is just integration of 3 tangent theta minus 3 theta from 0 to pi over 3. So let's compute 3 tangent pi over 3 minus pi plus 0 plus minus 0 plus 0, which is just 0. And 3 tangent pi over 3 is tangent is 1 over square root of 3, 1 square root of 3, so it's going to be pi over 3, because this is pi over 6, pi over 4, pi over 3 value. So this is pi over 3 minus pi. Oh, what am I doing? Not pi over 3, the square root of 3. So it's going to be 3 times square root of 3 minus pi. So 3 square root of 3 minus pi. Yeah, so sorry. So the answer for this question is A. Okay, this question asks to find the area of the small shaded region. Okay, that is very indeed small. Not gonna lie. Okay, this region. So I'm gonna draw a line. I'm gonna just draw it around here again. It's like this. Wait, that's smaller actually. There we go. It's better. So this region, right? This is the colored region. And I'm gonna draw a line here. So this is gonna be 0, and this is gonna be pi over 2, because it's the 1/4 of the quadrant. Okay, so if you want to find the area of this region, you have to do the area function of the polar curve. So A is 1 over 2. This is from 0 to pi over 2, because it's from 0 to pi over 2 here. And then theta squared, because it's r squared. And then compute this. So this will become 1 over 2 of 0 to pi over 2. Theta squared, theta cube over 3, 0 to pi over 2. So this is going to be, this is just, just this part. I can bring another color, right? So let me do that. So the region that I'm finding right now is just this much. So, okay, 1 over 2 times pi over 2 cube times 1 over 3. This is 1 over 6 times pi cube over 8. So this is going to be pi cube over 48. But we only found the half. And we want to find the other half, which is the symmetrical, which is why you do 2a is pi cube over 48 times 2, which is pi cube over 24, which is the answer choice D. So the answer is D. Okay, this question asks to find the function represented by the following power series. Okay, so you can write this into k equals 0 to infinity x to k times x cubed over 2 to the k power. And I can take out the x to the 3 power. So x3, k equals 0 to infinity x to the k over 2k. So they are both in the k power, so I can group this as x to the cube, k equals 0 to infinity x squared 2 to the k power, right? And if you recall, 1 over 1 minus x is equal to k equals 0 to infinity x to the k, x is less than 1. So this is the similar format, right? Because it's x squared over 2 to the k power. Instead, you just have to plug it in x squared over 2 in here. So this will just become x cubed, k equals 0 to infinity. We don't need that part actually. X cubed times 1 over 1 minus x squared over 2. And this is less than or equal to x squared over 2 over absolute value of that is less than 1. So if you compute this, simplify this, this becomes x cubed over 1 over 2 minus x squared over 2. So, and then this just comes down as well. So this becomes x cubed over 2x squared times 2 over 2 minus x squared, which becomes 2x cubed over 2 minus x squared. Okay, we have the function now. We have to find the bound, right? Let's eliminate some of the options. So 2x cubed, so it's not going to be A, B, D, F. So it's going to be either C or E, so we just have to check the bound. So it's x squared over 2, absolute value of 1. You can take out the 2 out, x squared over 2 is less than or 1. So x squared is less than or 2 because you multiply 2 on both sides. And this just becomes x is, you can take out the square, so x absolute value is less than or equal to square root of 2. So the answer for this question is C. Okay, this question asks to find the volume of the solid generated when the region bounded by the following two curves. Okay, let's draw the curves first. So the region is y equals x minus x squared, which I can group that by x, so x1 minus x, 0 to 1. Okay, like this region, and then y equals 0. Okay, y equals 0. Cool. And then, oh, wait, yeah, right. And then it's revolving around the y-axis, so it's this looking thing. So the region is in here, right? I think I can use the Chaewon method for this question. If you notice, I don't really use the Chaewon method very much because I am a more big fan of like this method. But I'm going to use the Chaewon method because this one is much easier to solve with Chaewon. So if you find the Chaewon method, use the Chaewon method. If you recall the Chaewon method, that's what I was supposed to say. It's parallel to the axis, right? So the cutting shape slice would be like vertical like this. So okay, that makes life a lot easier. So b is equal to 2 pi of vertical line. The radius would be x, because it's just this. It's this radius, right? This is just x, because the function is just with respect to like x, and then the axis at y equals 0, so it's just x equals 0, which is why the radius becomes x. And you have to find the height, which height is just x minus x squared, so it's going to be just x minus x squared dx. And this is from 0 to, what is this line? This is 1, right? Because I found it as x is 1 minus x, and then that graph crosses the x-axis at 0 and 1, so this just becomes 0 to 1. Okay, so, oh, not that. So this becomes 2 pi, 0 to 1, x squared minus x cubed dx. I expanded, and then if you integrate this, this is 2 pi of x cubed over 3 minus x to the 4th power over 4, 0 to 1. So this becomes 2 pi, 1 over 3 minus 1 over 4. If you do the lower bound 0, this just becomes 0, so I didn't calculate that part. 2 pi of 4 minus 3 over 12. So this becomes 2 pi times 1 over 12. So this becomes pi over 6. So the answer for this question is F. Okay, this question asks to find the length of the cardioid curve. Okay, the length equation says L is equal to 0 to 2 pi r squared plus dr over d theta squared, square root of d theta. Okay, r squared is 1 plus cosine theta squared, which is same as 1 plus cosine theta squared plus 2 cosine theta. We have that. dr over d theta, let's define that. dr over d theta is just negative sine theta, and then dr over d theta squared is negative sine theta squared, so this is just going to be sine squared theta. If you add those up, value r squared plus dr over d theta squared becomes 1 plus cosine theta squared plus 2 cosine theta plus sine theta squared. If you recall trig identity, cosine theta squared and sine theta squared becomes 1. So this is just 1 plus 1 plus 2 cosine theta. So this is 2 plus 2 cosine theta. Okay, so this is just integrating from 0 to 2 pi, square root of 2 plus 2 cosine theta d theta, group it by 2, 0 to 2 pi, square root of 2, 1 plus cosine of theta d theta. Okay, and now if you recall the trig half angle identity or half angle formula, more like 1 plus cosine of theta is equal to 2 cosine of squared of data over 2. You just have to remember this formula. Especially for the length of the cardioid, it's going to be a lot of times it's going to be half-angle theorem, half-angle formulas, so you just have to remember what is 1 plus cosine theta or 1 plus sine theta values. So in our case, it's 1 plus cosine theta, so 1 plus cosine theta is same as 2 times cosine of squared theta over 2. So plug it back in, 0 to 2 pi, 2 times 2 cosine of squared theta over 2 d theta. This is 0 to 2 pi, 4 cosine of squared theta over 2 d theta. And the square root of 4 is same as 2, so 0 to 2 pi, 2, and then square root of cosine of squared theta over 2 d theta. And if you recall, this is square root and squared, so this becomes 2, 0 to 2 pi, cosine of theta over 2, but this is going to be absolute value because negative sign will also have a negative cosine theta will also have the cosine squared, so you have to consider the negative value as well. So it's going to be 2 times 0 to 2 pi cosine of theta over 2 d theta, but I'm going to make it as positive for this one, and in order to do that, you just have to do multiply by 2 times 2, which, yeah, I'll just write it like this. You have to multiply by 2 and then decrease the bound into 0 to pi, and 2 times cosine of theta over 2 d theta. If you do that, this will make it as a positive value because cosine function is symmetrical. That's why. So this becomes 4 to 0 to pi cosine of theta over 2 d theta. Okay, and then if you integrate this is 4, not 1 over 2, 4 times 2 sine theta over 2, 0 to pi. So constant can become out 8 sine pi over 2 minus 8 sine 0, 0. So this, and sine pi over 2 is like 1. So 8 times 1 is 8. So the answer for this question is B. Okay, this question has to convert the polar equation to a Cartesian equation. Okay, so I'm going to multiply by cosine theta plus sine theta in both sides to get rid of the denominator. So this becomes r cosine of theta plus sine theta is equal to 1. R cosine of theta plus r sine theta is equal to 1. And if you recall, x is equal to r cosine theta, y is equal to r sine theta. So this becomes x, this becomes y, plus y is equal to 1. Y is 1 minus x. So this is exactly the same as C, so the answer is C. Okay, this question asks which of the following represents x comma y is equal to negative square root of 3 times negative, not times, comma negative 3. Okay, so our value is found as square root of x squared plus y squared. Let's do that. Negative square root of 3 squared plus 3 squared is same as 3 plus 9, which is square root of 12, which is 2 square root of 3. So r has to be 2 square root of 3. That means not gonna be F, B, A, and C. Okay, so either it's gonna be D or E. Let's try finding that. And then our theta value is tangent inverse of y over x, so negative 3 over negative square root of 3. So it's gonna be same as tangent inverse of 3 over square root of 3, which is same as tangent inverse of just square root of 3, which is pi over 3. Which is why some people might have just chose pi over 3. But recall that our point is at negative square root of 3 and negative 3, so this point is actually at the third quadrant. So even though we found the value at pi over 3, you have to add plus pi to find the value because the quadrant is not in the first quadrant because of the value. So add pi over 3 plus pi, so this becomes 4 pi over 3, which is why the answer for this question is E. There we go. Okay, this question asks to find the sine theta squared and cosine theta squared. The theta is from 0 to pi over 3. Okay, I'm going to group it by sine theta and then cosine theta because they have the same power of 2. So 2 theta. And if you recall that the double angle theorem, double angle formula, sine to theta is same as 2 sine theta cosine theta. So sine theta cosine theta becomes sine 2 theta over 2. So swap the value. So sine 2 theta over 2 squared d theta. This is same as 0 to pi over 4. Sine to the 2 theta over sine 2 theta, sine 2 theta squared. Well, actually, yeah, sine 2 theta squared, and then over 4 d theta. Okay, so how am I supposed to solve this? I see. Okay, so sine 2 theta, right, sine 2 theta. Okay, cool, got it. So when you have the sine 2 theta squared d theta, you can take out the constant, right? So this is going to be 1 over 4, 0 to pi over 4, sine 2 theta squared d theta. And if you recall your half angle formula, this is sine 2 theta, right? Sine theta squared is same as 1 over 2, 1 minus sine theta squared is 1 over 2, 1 minus cosine of theta, d theta or something like that. But since our value is sine 2 theta, it's gonna be 1 over 2, 1 minus cosine of 2 theta. Oh wait, it's 1 over 2, 1 minus cosine of 2 theta, d theta. But since our value is actually sine 2 theta, you have to times 2 d theta. So this becomes 1 over 2, 1 minus cosine of 4 theta, d theta inside in here. So this is going to be 1 over 4 times 1 over 2, 1 minus cosine of 4 theta, d theta. Okay, now we have that. And then it's from 0 to pi over 4. 1 over 4 and 1 over 2 is 1 over 8. 0 to pi over 4, 1 minus cosine of 4 theta, d theta. If you integrate this, this is 1 over 8 times theta minus sine 4 theta over 4, integrating from 0 to pi over 4. So this is 1 over 8 pi over 4 minus sine of pi minus over 4, and then minus 0 plus 0. This is just 0. So this becomes pi over 32 minus sine pi over 32, which sine pi is 0. So this becomes 0. So this is only pi over 32. So the answer for this question is B. Okay, this question asks to evaluate the following series, 1 over 2 to 2k plus 1. This is geometry series. Okay, let's do that. So k equals 0 to infinity, 1 over 2 times 2k times 1 over 2. You can separate this, right? 1 over 2 to 2k plus 1 into 1 over 2 to 2k times 2 to 2k. And then take out the constant, 1 over 2, k equals 0 to infinity, 1 over 2 to 2k. And this is 1 over 2, k equals 0 to infinity, 1 over 2 to 1 over 2 to second power to the k power. You can do that, right? You can group it by this. So this becomes 1 over 2, k equals 0 to infinity, 1 over 4 to the k power. If you remember your infinite sum of series, which is x to infinity, which is a over 1 minus r. A is the first term, and then r is the ratio, and r has to be less than or equal to 1 for the absolute value, and which satisfies our condition. So we can find the a value, which is our first term, which is 1 over 4 to the 0 power, which is 1. Ratio is 1 over 4. So this becomes 1 over 2 times 1 over 1 minus 1 over 4, which is 1 over 2 times 1 over 3 over 4. So 1 over 2 times 4 over 3, which becomes 2 over 3. So the answer for this question is B. Okay, this question asks to find the series expression for 0 to 1 tangent inverse of x squared dx. Okay, let's do that. We are given the tangent inverse of x is given as that formula. So we just have to swap into x squared. Tangent inverse of x squared is becoming k equals 0 to infinity, negative 1 to the k x squared 2k plus 1 over 2k plus 1. This becomes k equals 0 to infinity, negative 1 to the k, x to the 4k plus 2 over 2k plus 1. Okay, and then we are and this integral is evaluating from 0 to 1 dx. So if you integrate that, you can take out the constant 0, k equals 0 to infinity, and then 2k plus 1 and negative 1k. And this is going to be then x for k plus 1 because you're adding the power in the integral when you're integrating. So you do that, and then you have to divide it by the constant for k plus 3. So that's the equation for our integration, and this is evaluating from 0 to 1. Okay, so we have that. And then if you plug it in 0 to 1, let's see. If you plug in 0 to 1, 1 will be just negative 1 to the k. 1 will be just k equals 0 to infinity, and then negative 1 to the k over 2k plus 1 for k plus 3. And if you plug in 0 for the x, that just becomes 0. So this is our equation. Okay, finally, we have that. And then now let's plug in the first term, k equals 0. What do you get? K equals 0, 1 over 1 times, 1 over 1, 1 over 3. 1 over, because you plug in 0 in here, negative 1 to the k is 0. Then that becomes negative 1 to the k, negative 1 to the 0 power, which is 1. And then 2 to the k, 2k plus 1 becomes 1. And then the second term will be just 3. So this is going to be 1 over 3. Okay, and then let's do the second one. K equals 1. This is going to be negative 1 over, and this is going to be 3 times 4k plus 3, so times 7. So 1 over 1 times 3 minus 1 over 3 times 7. So let's try looking at our answer choices. It has to be starting from 1 over 1 times 3. So this is not going to be A, B, C, E. So it's going to be either D or F. But our second term is 3 times 7, which is exactly the same as F. So there you go. The answer is F. Okay. This question asked to find which series is diverging. So let's find it. So A, it's 1 over 4 squared plus 2 over 5 squared, blah, blah, blah. So this is going to be n over m plus 3 squared. And it's starting from n equals 1 to infinity. I'm going to use the limit comparison test, so LCT. So it's going to be n over m plus 3 squared of limit of n goes to infinity over, not absolute value, 1 over m plus 3 squared, right? So this becomes just n, right? If you do the calculation. So n is infinity because limit of n goes to infinity, so infinity is actually greater than 0. But if you remember the limit comparison test, it has to be finite and positive value. So it's not finite, so it's going to be diverging. So A is not right. Wait, actually, that is the answer then. Okay, so we're done, but I'm going to go over all the other options. So B is 2 over 1 factorial plus 2 squared over 2 factorial, blah, blah, blah. So this is same as series starting from 2 to the n over n factorial when n is equal to 1 to infinity. So this is the series, and we can use the ratio test for this one. So limit of n goes to infinity, 2n plus 1 over n plus 1 factorial divided by the original 2n, n factorial over 2n. So this becomes 2n times 2 over n plus 1 times n factorial times n factorial over 2n, and then 2n and n factorial can be cancelled out. So this is 2 over n plus 1. And if the limit of n goes to infinity, 2 over n plus 1 is just 2 over infinity, which is 0, which is less than 1, so it is converging. So it's not B. Let's try C. Okay, 1 plus 1 over 2 square root of 2, blah, blah, blah. This is same as n equals 1 to infinity, 1 over n square root of n. Okay. So this is same as 1 over n 3 over 2. So this is by p series test. The 3 over 2 is greater than 1, so this is converging. Okay, D, let's try it. 0.9 plus 0.9 squared, blah blah blah. So this is n equals 1 to infinity, 0.9 to the nth power, which is same as n equals 1 to infinity. It's 9 over 10 to the 10nth power, and this is by the geometric series test. So it's gonna be converging, but you can also use the ratio test to check. So this is gonna be 9 over 10 to the n plus 1 power divided by the original 10 over 10 to the n power over 9 to the n power. This becomes 9 to the n times 9 over 10 to the n times 10 times 10 to the n over 9 to the n power. 9 to the n, 10 to the n power cancelled out, which becomes 9 over 10, which is less than 1. So this is going to be converging by the ratio test and also geometric series test. So D is not diverging. Okay, let's try E. So E, wait, is that E? Oh, that was E, sorry. That was E. We didn't do D, I see. I'll do D now. Okay, D. D is 1 minus 1 over 2 plus 1 over 3, blah blah blah. So this is like negative 1 to the n plus 1 power 1 over n is equal to 1 to infinity. Okay, we have that form. And now, since the signs are alternating, I'm going to use the AST, alternative series test. So AST, so 1 over n, and limit of n goes to infinity, that goes 1 over infinity, which is 0. So we met the first condition, and is it decreasing? Yes. 1 over 2, 1 over 3, so it's constantly decreasing. So this is also decreasing, so this is converging, so this is not diverging, and E is also not right. Last one, F. Okay, F is minus 1 over ln 1.2 plus blah blah blah. So this is same as negative 1 to the k, 1 over ln 1 plus 0.2k, where k is equal to 1 to infinity. Okay. So this is also signs are alternating, so I'm going to use the alternative series test. So, right, yeah. So, yeah, right. No, I was thinking whether you can solve D as telescoping series as well, but yeah, you could have done the telescoping series, but yeah. You can do an AST, I think that's a little faster to solve it, actually. So you can do AST, or you can do telescoping series to solve D. But going back to F, sorry. So it's AST, alternative series test. So if you apply that, this becomes 1 over ln of 1 plus 0.2k, right? And then if limit of k goes to infinity, this is going to be 1 over ln of infinity, which is ln of infinity, which is 0, which is indeed 0. And then is it decreasing? Yes. 1 over ln of 1.2, ln of 1, actually, and then ln of 1.2, and then 1 over ln of 1.4, blah, blah. So the values are constantly decreasing, right? So it's meeting the alternative series test. So it is converging. So it's not diverging, so the answer is as we expected, A. Okay, this question asks to find the work of how much work is required to pump all the water out. So it's a cylindrical tank like that, and then has a height of 4 meters and the radius is 1 meter. Cool. So force is equal to PGmV, and the only reason that we are finding the force because work is force derivation. So PG, you just have to keep it like that, and V is 1 times 1 times pi because of the base, and then you have to multiply by the height, which height is changing, so it's gonna be dy. So PG pi dy. So, and then If you remember, work is 4 times this distance. I forgot to write the distance. Yes. So this is pg pi dy, and the distance, which is constantly decreasing, which is 4 minus y dy. So, and this is the tricky part. It's already half full, so it's gonna be just 0 to 2. So the work is pg pi 0 to 2, 4 minus y. I wrote dy twice. I figured dy. Okay, so pg pi, and then this is going to be 4y minus y squared over 2, integrated from 0 to 2. So this becomes pg pi 8 minus 4 over 2, and then minus 0 over 0. If you plug in 0 for both y, it's going to be 0. I'm just not going to calculate it. So pg pi is 8 minus 2, which is 6 pg pi. And so the answer for this question is F.